Hello, BC Calculus students. This is the first lesson of the first unit of BC Calculus. And hopefully this is review from either Pre-Calculus Honors or AB Calculus. But today we are going to go over everything that has to do with limits. We'll take a look at limits from a table, limits graphically, and limits algebraically. And just so you know, in calculus, we call limits algebraically, we call it analytically. So if you hear the word analytically, it means algebraic. So the first thing we'll do is take a look at the function g of x equals x squared minus 9 divided by x minus 3. This is a rational function, and we want you to complete the table of values. I went ahead and did this by using Desmos to figure out all of these values because I didn't want to sit here doing it with you online. So what I'd like to do right now is just show you the values that I found when I used Desmos. I got x equals 2.9 gave me 5.9, 2.99 gave me 5.99, and you can go ahead and copy this table of values onto your notes. And you'll see that when they ask us what g of 3 is, well, g of 3 is undefined per the table of values. So we would just write UND right here for undefined. The domain of g, because the function is undefined at 3, the domain of g is going to be all real numbers except for where x equals 3. The next question is, as the values of x get closer and closer to 3, what value does g of x get closer and closer to? So when you look at these values of x as we go closer to 3 from values less than 3 and closer to 3 from values greater than 3, my y values are getting closer to the number 6 from both directions. So that means the y values, or g of x, are getting closer to 6. We state that as x approaches 3, g of x approaches 6, and this little arrow here means the word approaches. So we state in formal notation that the limit as x approaches 3 of the function g of x is equal to 6. So in general, this notation is read as the limit as x approaches a of the function f of x is equal to L, which is the limit. So let's do a practice problem. Go ahead and take a look at this limit. It says the limit as x approaches 0 of the sine of x divided by x. And we're working on limits numerically. So what I'd like you to do is come up with a table of values on your own paper, and then in your calculator, evaluate those table of values for to find out what the actual expression sine of x over x is approaching. I will pause the video here, or I would like you to pause the video here, do this work, and then come back and check your answers. Okay, so I went ahead in Desmos and came up with these x values, so negative 0.1, negative 0.01, negative 0.001, negative 0.30 and a 1, and then I flipped to the positive side. And what I see here is that my y values, as I'm moving toward the value of x equals 0, my y values are approaching 1 from both sides. So as I approach 0 from below 0, my y values are actually so close to 1 that it looks like they round to 1. And then same from the more positive y values. As we approach x equals 0 from the positive side, we are also approaching 1. So that means the limit as x approaches 0 of the sine of x over x is equal to 1. And actually, I would argue that for this problem, we would write approximately equal to, because unless we had our algebra, we wouldn't be for sure certain that this limit is equal to 1. So we could go back up actually to this limit of g of x as x approaches 3 and also say that it approximately equals 6. And the only time we're going to get a true equal sign out is if we use algebra to simplify.